Hey guys, we are going to look at 6.3, which is finding probabilities with normal distribution. Let me go find this stuff. Give me just a second. All right. Nope, it didn't come up. All right, let's try this again. All right, so we are going to be learning about 6.3, finding probability using a normal distribution. All right, so we're going to calculate probabilities for the normal distribution. If you looked at 6.2, I actually broke it up into 4 parts. So let's look at this problem. So this is finding a probability that normally distributed random variable will be less than a given value. Remember, that means less of the mean. So we go. Body temperatures of adults are normally distributed with a mean of 98.60 degrees Fahrenheit with a standard deviation of 0.73 degrees Fahrenheit. What is the probability of a healthy adult having a body temperature of less than 96.9 degrees Fahrenheit? Okay. So we're looking for less than 96.9 degrees Fahrenheit. So we want to convert 96.9 to a standard score. So we use the z-score. And if you see here, we get negative 2.33, which means it is 2.33 standard deviations below the mean. So we're going to put it into our calculator. So I don't want you don't have to use the table unless you want to. So if you're finding out, when you're looking in a calculator, you get negative 2.33. If you've looked in the book, you get 0.0099 when you looked it up on the table. So, but what we're going to do is we're going to actually put it into the calculator. So normal CDF, parentheses, negative 1 E99, comma, then you're going to put in your value that you're looking for, next is your mean, next is your standard deviation, and then you close parentheses and you get 0.0099. And you only have to give me 4 decimal places. All right, so let's do a different one. Let's do a greater than. So 98.60 is your mean, 0.73%, excuse me, 0.73 is your standard deviation, and 97.6 is your X value. And for this one, we're actually looking for body temperatures greater than 97.6. So first thing you're going to do is convert that to the standard score. If you look here, then we know this is still 1.37 standard deviations below the mean. How do I know below the mean? Because of that negative sign. So we're going to put this into your calculator, because we don't want to have to worry about looking it up in the table. So when you're using it, you're going to convert it. So you're going to do normal CDF, comma, 97.6, and then you're going to flip it and go 1 to 99, because the 1 E infinity, comma, your mean, and then your standard deviation. So when you do that, normal CDF, remember the X value, comma, the value going to infinity, comma, the mean, comma, the standard deviation, you get, 0.9146 is your answer. All right, let's do it between 2 values. Your mean is 98.6. Your standard deviation is 0.73. What's the probability of a healthy adult having a body temperature between 98 and 99? All right, so now we've got to do a between scenario. So how would we do that? Well, we're going to have to solve for 2 z-scores. So here we have, for the 98, we solve and we get negative 0.82. And for the 99, we get 0.55. And all we did was put them into the z-scores. So then we need to put it into our calculator. So it's pretty easy for this one. You just got to do normal CDF, comma, negative 0.82, comma, 0.55, which gives you a value of 0.5027. And that's all you do. To me, this is the easiest one because there's only 2 things you have to remember. Okay? Then let's see. It shows you how to put it in. Okay? So you could do normal CDF. If you don't want to convert to the z-scores, you can do 98, comma, 99, comma, the mean, comma, the standard deviation. and then you get the answer. So there's two ways to do it. It's just up to you how you want to do it. Right. So we'll be in the tails definition. Body temperature of adults are normally distributed with a mean of 98.6 and a standard deviation of 0.73. What is the probability of a healthy adult having a body temperature less than 99.6 or greater than 100.6? All right, so we still have two things we have to look at. Remember, that first way we can do it is we can convert them to z-scores, 1.37 and 2.74. And then what we can do is we can go ahead, and we have to do them separately. We can do normal CDF of negative infinity to 1.37 gives you a value, and the normal CDF of 2.74, comma, to infinity gives you 0.0030. So you have those two values, and you just add them together. Or you could do 1 minus the normal CDF, do your first value, then your next value, then your mean and your standard deviation, and it gives you the same thing. To me, that's easier. So just find the way that works for you. All right, so let's do this. Body degrees of adults are normally distributed with a mean of 98.6 degrees and a standard deviation of 0.73 degrees. What's the probability of a healthy adult having a body temperature that differs from the population mean by more than 1 degree? Because we want the temperatures to differ for the population mean by more than 1, we need to add 1 degree to and subtract 1 degree from the mean to get the temperatures in which we're interested in, because we're kind of looking at the range. So we do this by doing, we want to know values less than 97.6 and greater than 99.6, because all I did was subtract 1 from the mean and then add 1 to the mean. Okay. Again, you can do it as the standard score, and if you solve for this, you get negative 1.37 and positive 1.37. You can put that into the calculator and you get 0.1706, or you can do the normal CDF, 97.6, 99.6, the mean and the standard deviation, and it gives you your value, 0.1707. I hope this helps, and let me know if you have any questions. Thanks.